Welcome to Essential Problems of AP Chemistry. This video assumes that you have a strong understanding of using the periodic table to find any electron configuration associated with an element. In this type of problem, you will be provided with a photoelectron spectra of an unknown element and be required to determine its identity. The key is focusing on the lowest energy sublevel, 1s, first, every single time. 1s always requires the greatest amount of energy, no matter what element you have. So determine which peak corresponds to the 1s sublevel first. The peak associated with the highest amount of energy required, using the x-axis, is leftmost. This must be 1s. The next peak therefore must be 2s and the following 2p. Based upon a relative comparison of the peaks, if there are 2 electrons in 1s and 2 electrons in 2s, due to the Aufbau principle of filling lower sublevels before the higher, this configuration must end in 2p2. Therefore, this element is carbon. Using the tick marks, we can see that 1s and 2s were 4 marks high, but in the case of 2p, it is 6 marks high. Therefore, this 2p sublevel is holding 3 electrons, and its identity must be nitrogen. Now in this case, the tick marks is 8 high. 2p is holding twice as many as 1s and 2s, therefore this element ends in 2p4 and is oxygen. In this case, 2p has been filled, and the next sublevel, 3s, only has half as many as 1s and 2s. Therefore this element is sodium. If we write out the full electron configuration for this element, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, this element is clearly calcium. Finally, if we were provided with 2 elements, we should use exactly the same logic. The graph at the top must both have lone peaks of 1s sublevels, since these are 2 different elements. Therefore, one must be 1s1 and the other 1s2, since 1s can only hold 2 electrons. Therefore, the left peak represents helium and the right is hydrogen. This makes sense because helium has a greater number of protons and therefore greater electrostatic attraction to its electrons. The next graph shows lithium spectrum in blue with helium's still in red. Signing off, Crip.